أهلا بكم في قناتي سات ماث 800. Today's lesson is about how to get the range of a function. The last video we talked about how to get the domain. When we talk about linear function, as an example f x equal x plus 3, we will find the range. To get the range, we are looking for the y-axis, and we will try to find the domain. We look at the x-axis. The range for a linear function is extended to from minus infinity to infinite. There is an odd degree polynomial. They are the polynomials that has the biggest term in this function. The exponent or the power is odd. It's to the power 3, it's to the power 3, it's to the power 5, to the power 7. Any polynomial of odd degree, their range extend from minus infinite to infinite, and it's also the domain is from minus infinite to infinite. They also talk about the linear function is an odd degree polynomial, so it has the same range and domain. Now let's talk about the quadratic function. Yesterday we said that quadratic function, all the domain in quadratic function was minus infinite to infinite. Now let's discuss the range. The range of the quadratic function depends on how to get the vertex. It depends on the vertex of the quadratic. There is always a vertex in quadratic. This vertex, it can be when the parabola is open upwards. It can be minimum. We start from here to positive infinite, and if it is looking downward, this point will be a maximum point, so the range will take the range from minus infinite to this maximum point. So in every quadratic equation we have to get the vertex of the parabola, because we depend on it to get the range. And also, as I said before, we look at the y-axis. The y-axis here, the minimum value is from 0 to infinite. In this case, x squared minus 3. The minimum here is in the y-axis is minus 3 to infinite. For this kind of quadratic equation which are looking downward, we will say the range is from minus infinite to 4, because 4 here is a maximum value. If the vertex is not observed, we will get it from the law minus b over 2a to get the x is 2, and substitute in the function to get the y, and we will say range start from 1 and to infinite, since it looks upward. Of course, 1, 4, negative 3 and 0, all of these intervals are closed. This point is include in the interval. Let's see the absolute function. It's the same idea as the quadratic function. This function has a vertex, and this vertex determines the range of this function. And all the domain for all the kind of absolute function are from minus infinite to infinite. Let's see the range for this absolute value. It's a minimum value. It's from 0 to infinite and closed 0. If we deal with function like absolute x plus 3, we will start from 3, because we are looking for on the right axis, starting point is closed 3 to infinite. If we look at absolute like this, we will take the y as it is and with its sign, we will take it -3, and we will take the positive. Here is negative -2, we will take 2. Change the sign of 2, we will take it here, it's -2, we will take 2. And we will see the y coordinate. Y coordinate is starting from, now the vertex is a maximum value, so we will start with 3 and go to -infinite. Of course, we will start with -infinite to 3. This is, now we will talk about the radical function. We see all the radical function, it starts from 0. It's just, there is change in the sign. There is negative before the root, there is negative inside the root, and there is 2 negative, 1 inside and 1 outside. But all of these are starting from 0 because they are parents of the function. For this function, we will see that we will talk about the range. We will see, so we will see in the y-axis, it starts from 0 and it extend to positive infinite. That's positive infinite. And also for the x-axis, as we talk about the domain, it starts from 0 and goes to infinite. For this equation, there is a negative before the root, so it is a reflection of this function. This is a reflection about the x-axis. This function starts from 0, and when we talk about the x-axis, as we talk about domain, so we will start from 0 and extend to positive infinite. But when we talk about the y-axis, we talk about range, so we will start from -infinite and 0 will be the maximum value, because we are getting the negative y-axis. For this one, the negative here is inside the radical, so it's also a reflection of this function about y-axis. When we talk about the range is y-axis. It starts from 0 and extend to positive infinite. But according to x-axis, it starts from 0 to negative infinite. But we always put, when we put the numbers in the interval, we start with the smallest number. So we start with negative infinite to 0, because 0 here is maximum value. For this function with 2 negative, it's a reflection 2 times the reflection of this. This function reflect here, the first reflection, and it's also reflect about y-axis, so it gets in the 4th quadrant. When we see this, when we talk about the range, the range is in the y-axis, start from 0 to -infinite. But as I said before, we will start with negative infinite to 0 as a maximum value. And also the same to the domain. It starts from 0 and get to -infinite, but we start with the smallest value. In these radicals, we shift the starting point according to the function. In this function, we take, this is the point 2, we take as it is with this with its sign, and we take the opposite of the sign of x. Here is -1, we will take 1, and we will say that this is the starting point of this radical. This is the starting point of this radical. As x is positive and before x is positive, so it will go in the same direct as this. The second one, there is a negative before the x. We will determine also the starting point. It's 3 to the y and negative 1. So the starting point will be negative 1 and 3. And as we see here, when there is negative before the root, it will be graph in the fourth quadrant. That's all these radicals are drawn as the same radicals before. This is a starting point, so the domain will change and the range will change. The domain, as we talk about the domain, we are talking about x-axis. So we will start with 1 closed and to infinite. And if we are talking about the range, so we will start with 2 and go to infinite. This function starting point is minus negative 1 and 3. So x shifted by negative 1, so the domain will change. It will start from negative 1 to infinite, and the domain shifted to be 3, so the domain will be negative infinite to 3. We will take also the starting point from there. We will take 1 with their sign, and we will change the x sign. There is negative inside the radical, so we will draw it at the second quadrant. Here, the range, we are talking about the y-axis. The y shifted by 1, so we will start from 1 to positive infinity. And the x-axis shifted by negative 3, so it will start with negative 3 to minus infinite, or we will start with negative, so it will start from negative infinite to negative 3. And this should be closed 3. If x there is 2 negative, so it will be drawn in the third quadrant. This shift the opposite sign, it's 2, and the same side sign 2, so it shifted 2 in the x-axis and 2 in the y-axis. So the range and domain, the range we are talking about the y-axis, it shifted from 2 to negative, because we are talking about y, so this is negative y, so from minus infinite to 2. When we talk about the domain, we start from 2 as an x-axis, and it will go to minus infinite, and we start with minus infinity. Now we will talk about the reciprocal function. What is a reciprocal function? It's a fractional function, but the numerator has a constant. In this kind of function, we take the y with its sign to draw the horizontal asymptote. What is the horizontal asymptote? It's a boundary that the function can't touch. And also we will take the negative, the opposite side of negative 2 and make a vertical asymptote, x equals 2. So we will draw 2 straight lines. They are boundary lines. One of them we take from the number of the y here. We said y equals 4. And we take the other asymptote from negative sign of the x equal 2. So we draw the 2 boundaries here, and we draw this graph. This is the graph of a fractional number or a reciprocal. We will see here the domain and the range. We said that these are boundaries. The function can't touch it. it can extend from here to positive infinite, to extend here to positive infinite, and here negative infinite and negative infinite, but it can't touch these two boundaries. So the domain will be, here is, we are talking about the domain, we are talking about the x-axis. All the x-axis is acceptable to be a domain except for the number 2. So we said that the domain is from minus infinite and 2. 2 is open because we can't get 2 with us. Union from 2 to infinite. We take all these x-axes and we took all these x-axes, and there is a point we can't put in the domain. It is number 2. When we talk about the range, it's the same thing. We can take all the y-axes except for the boundary y equal 4. So we will say that r equal from minus infinite to 4 union 4 to infinite, and we can express it in a different way. We can say that all the real number except for 2. The ordinary reciprocal function are drawn in the first and third quadrant. When we put negative in the numerator, that affect this x, and it be in the second and fourth quadrants. And we will make all the steps we done here. We will take 2 and make a horizontal asymptom, and -1, the opposite of this, it's -1. This is the vertical asymptom. We will make 2 boundary straight line. We can't touch these 2 lines. So we say that the domain equal from minus infinite to -1 union -1 to infinite, and we have to check this is open. When we talk about the range, it's also from minus infinite to 2 union 2 to infinite. Now we will make a summary. We will take general tips to finding domain and range. In the domain, there is 2 restrictions. The first restriction is the fractional function. In the fractional function, we can't make the denominator equals 0. The second restriction is in the radical function. In the radical function, we are talking about the even root. H is even. It has to be even. We are not. There is not a problem in the odd root, because the cubic root we can have outcomes from the cubic root is negative, and that is normal. But it's not normal to have a negative under an even root. So we exclude all the negative numbers from all square root or all even roots. We have 2 cases. When the radical is in the numerator, we have to check that it is greater than or equal 0. And if the root is in the denominator, we have to check it is greater than 0 and not equal to 0. Greater than and not equal, because there is no 0 in the denominator allowed. When we talk about the range, the domain of a function is always defined on the x-axis. The domain on the x-axis, horizontal axis, and the range of a function is defined on the y-axis. The vertex of function, some kind of function have vertex, like the absolute function, the quadratic function, and we can say the radical function also. These vertex of this function, the vertex for polynomial, especially quadratic and absolute value function, the vertex help determine the boundary of the range. We stop here in the vertex and say that the range starts from here to infinite. And if it is the vertex maximum value, we say that the range is minus infinite to the vertex as a maximum value. Hope you enjoy our video today. Don't forget to like and subscribe.